Today we're going to do something called composite functions. Now, the good news is that composite functions now is also part of regular math. I hope you guys are aware. It was always a part of IGCSE Math, but now it's part of O-level math as well. So you guys, if you guys have done it already, you won't have a hard time understanding this. But even if you haven't, it's still very easy. Okay, composite is easy. The difficult part is domain and range, and then there is inverse, in which once again we'll have domain and range. That's the difficult part. Composite is the easy part. So composite functions is what we're doing. So what's a composite function? By definition, it is basically a function made of two or more functions. It's when you plug in one function into the other, then what you get is a composite function. Sir, do you have a list of concepts we cover for functions like we did for trigonometry? I do. I guess you're right. I didn't mention the concepts in the beginning. Okay, I'll update the notes inshallah over the weekend and upload them. Okay. So here is an example. Let's say that you have f of x, which is equal to 2x plus 1. Okay, and the domain, let's say you're given, is x belongs to the set of all real values. And let's say you're given g of x, which is equal to x squared minus 1. And here also the domain is given to you that x belongs to the set of all real values. Now, let's say that you are asked to find out fg. Now, how do we read this? We can call it f of g, or we can call it f of g of x. Same thing. The question might even, instead of giving you fg, the question might write it as f of g of x. So don't get confused. Okay, they both mean the same thing. Now, how do we do it? How do we find f of g of x? For those of you who know the answer already, that's great. For those of you who don't, I want to use a small analogy to explain the concept. So if, let's say, you're given f of x and you're asked to find perhaps, sorry, let's say that you are given f of x. Okay, so here's f of x, which is equal to 2x plus 1. And let's say you're asked to find f of 2. So what you're going to do is, in place of x, you're going to plug in 2. So whatever you see in place of x, you plug that in place of x. Okay, so if you see 2 in place of x, you plug in 2 in place of x. If, let's say, there was 3 in place of x, you'd plug in 3 in place of x. If, let's say, it was 500 in place of x, you'd plug in 500 in place of x. Okay, and then you would evaluate or whatever it is that you're supposed to do, simplify, whatever. But now if you see, let's say, f of g of x, what are you going to do now? Now what you're going to do is you're going to plug in g of x in place of x. So you're going to plug in not a value in place of x, but you're going to plug in an entire function in place of x. So f g of x basically means, or fg basically means that now in place of 2, we're going to have function g of x plus 1. So that's what we're going to do. Let's do that. Let's see what do we get. So fg is equal to 2 times x squared minus 1 plus 1. Okay, so you can see what I've done is, in place of x, I've plugged in x squared minus 1, which is basically function g, and the plus 1 remains as it is. Then when you get an expression like this, make sure that you expand and simplify. So this becomes 2x squared minus 2 plus 1, unless, of course, the question doesn't say, the question says otherwise. So 2x squared minus 2 plus 1 is equals to 2x squared minus 1. That's the answer.
Good.
Okay. So fg of x is basically read as f of g or f of g of x. Just a minute. And here what we do is we plug in function g in function f. Yeah, someone is saying something?
So if the question just says that find an expression for fg, so can you just leave it at the unexpanded form?
Dekho, whenever you have an expression which can be simplified, then you do simplify it. So if there's an expression which can be simplified, and the requirement prior to simplifying, you have to expand it, then you expand it and simplify. ठीक है, तो इसको हम इस form में नहीं छोड़ते. Normally the question is quite clear in situations like these. The question is quite clear, but I would suggest that you simplify. Okay, unless it's like a whole square or something like that, then you don't. But then it's up to you, read the question. But otherwise, I would suggest that you simplify. Can there be? Yeah, there can be 3 functions in a row, although that's quite rare. I haven't seen too many, but theoretically speaking, it is possible. So let's say this was part A. Now let's say there's part B, which is not FG, but it's GF. So what are we going to do over here? Here we're going to plug in. We are going to plug in function F in function G. We're going to plug in function F in function G. Okay, so let's do that. So G of F or G of F of X both mean the same thing. Please don't get confused. So x squared, but now in place of x, we have 2x plus 1. So that's function F and then minus 1. Now this you can leave as it is unless the question says something else. But make sure that you read the question carefully to get an idea of how the question wants you to give your final answer. No, like I said, questions are 95% of the time very clear as to how they want the final answer. Okay, now what if the question says f squared? What does that mean? Does that mean that we will take function f and we're going to square it?
So
Is
it
that what it
means
means?
we will plug function f into function f.
That is correct. Good job. So f squared basically means f. Okay, so I'll write an important note over here that f squared does not mean that you square the function. Okay, so ff basically means that you plug in function f in f. Okay, so I'll write another note that f squared of x is not the same as f of x, the whole thing squared, because sometimes you will have to take the square of the function, and this is what it's going to look like. If the question is asking you to take the square of it, this is what it's going to look like. Yes, this is included in math as well, Shumayan. So f squared or ff, that means 2 in place of x, we'll have 2x plus 1 again. And remember, the original function was 2x plus 1. So the plus 1 remains. So ff. So sometimes you will see colon also. Okay, instead of equals to sign, the question might use colon, or sometimes, in fact, the question might even use these arrows. So don't get confused. They all basically can be used instead of the equals to sign. So this becomes 4x plus 2 plus 1. So that means ff or f square is equal to 4x plus 3. That's the answer. Now, as always, take a good look at it. Let me know if you guys have any questions. Okay, great. Now, let's do a few example questions. Okay, so although the ones we did earlier were also some example questions, but now let's do some example questions. And we'll start easy. We'll start with some questions from the book, and then obviously gradually increase the difficulty level. What's the difference between the two f of x that you write under the note? Okay, I'll elaborate. This means f, which basically means that you plug in f in f, okay? Whereas this means that you square f of x, okay? Clear up? All right, now, the function f is defined by f of x. So remember what I was saying? Instead of the equals to sign, sometimes you might see these arrows. So don't get confused. It's the same thing. So here are some full-length examples that we are going to solve. So here is the first one. Now, g of f of x equals to 5. So first thing we have to do is we have to find out g of f of x. And then obviously we're going to equate it to 5. So this is the question, g of f of x equals to 5. G of f of x means that we're going to plug in function f in function g. So make these arrows to help you decide which function you're going to plug in into which function. So g of f of x means that 10 upon 2 minus, now in place of x, you will have 3x plus 1. And what's this equal to? This is equal to 5. Okay. So we have 10 upon 2 minus 3x minus 1 equals to 5. Now remember, you can always simplify across the equals to sign. So 5 ones are 5, 5 twos are 10. And then simplify before you cross multiply. So it's going to be 2 minus 1, which is 1, minus 3x, which is equal to 1. Now cross multiply. 2 is equals to 1 minus 3x. 3x is equals to 1 minus 2, which is minus 1. And that leads to the conclusion that x is equals to minus 1 upon 3. That's the answer. Okay, so fairly easy. A lot of it is just majority of questions like these will be very algebra intensive, as in you'll realize there's not a lot of concept that you have to know, but rather there's a lot of algebra that you have to do before you can get to the final answer. Okay, so here is another example. Let's see what this says. G of x equals to x squared plus 2 and h of x equals to 3x minus 5. So how about you guys try this? I'll give you a few minutes. Try this. Tell me what you get.
Sir, 4 and minus 2 over 3.
4 and minus 2 over 3. That is correct. So what do we get? G of h of x. A good idea would be to first write down exactly what the question is. So g of h of x का मतलब है that we have to plug in function h in function g. So make these arrows to help you decide what you have to do. So g of h of x means that 3x minus 5, the whole thing square, plus 2 is equal to 51. Okay, so in place of x, I've taken this function and replaced x with 3x minus 5 plus 2 as it is and equated it to 51. Now, you don't have to expand this, by the way. I mean, you can expand it and solve it, but jab bhi you have x inside a bracket with a square on it, take advantage of it and solve the quadratic equation without expanding. So 3x minus 5, the whole thing square will be equal to 49. And then how do we get rid of the square? We get rid of the square by taking the square root. So that's what we do. We take the square root on both sides. So the square root on the left-hand side and square root on the right-hand side. And remember what happens when you take the square root on both sides? You have 3x minus 5, which is equal to 7, or 3x minus 5, which is equal to minus 7. So you solve this, you get x is equals to 4, and then you solve this, you get x is equals to minus 7 plus 5, that's minus 2, so minus 2 upon 3. And both these answers will be acceptable. Why? Why is it that both these answers will be acceptable? Because in some cases, you'll realize that there is one value that we might have to reject because they are real values. Because if you look at the domains of both the functions, you will realize that this value comes inside the domains of both the functions. So that means this is a value that can not only be plugged in function g, but can also be plugged in function h. That's why it's acceptable. Okay, they come in the domain of both the values. Okay, now let's do another example. Okay, so now we're going to change the kind of questions that we're solving slightly. You'll find a slight difference, not like a major difference. So here's an example. Let's see what it says. So it says the function f is defined by f of x equals to so and so. The function g is defined by g of x, which is equal to so and so. Find g of f, which is equal to 18. Okay, what are we supposed to do? We're supposed to find g of f of 18. Okay, so now we have two options. For g of f of 18, we have two options. What are the two options? Let's see. So there's the simpler way and there is the longer way. One way is that you first find g of f of x and then you plug in 18. Okay, I think that's the most obvious way, but there's another way to do it as well. So g of f of x would mean that 10 upon, now in the denominator, we'll have function f, which is going to be 1 plus square root of x minus 2. Okay, minus 1. Now we can plug in 18. Now in this function, we're going to plug in 18. So 10 upon 1 plus square root of 18 minus 2, which is 16, minus 1. So that means 10 upon 1 plus 4, which is 5, minus 1. 10 upon 5 is 2. 2 minus 1 is equals to 1. So that means g of f of 18 is equal to 1. Okay. Now, who can tell me the other way? The
Sir,
other
can
way.
I? Sir, can I?
Yeah, go ahead.
Sir,
Please.
first of all, we will find f of 18 and then we will plug the answer in g of x.
That is correct. So what we do is we break this down into 2 steps. So here's the first step, that we find f of 18. Okay, so that's step number 1. F of 18 means that you simply plug in 18 in function f. So that's going to be 1 plus square root of 18 minus 2. So 18 minus 2 is 4. 4 plus 1 is 5. So f of 18 is equals to 5. Now notice that in g of f of 18, now that we know what f of 18 is equal to, we can simply replace it with that value, which is g of 5. So g of 5 means that 10 upon 5 minus 1. So 10 upon 5 is 2. And 2 minus 1 is equal to 1. So we get the same answer. Okay, we get the exact same answer, but the working is slightly different. One has a lot of algebra in it. One could potentially have a lot of algebra in it. Here we didn't do a lot of algebra because we didn't have to simplify or expand or anything, but it could potentially have a lot of algebra in it. The other was pretty straightforward. My personal preference is this method. Even in math and in add maths, this is the method that I prefer. Okay, so if you have any questions, let me know. Okay, great. Now I would like you guys to solve another
Sir,
question. Yeah, go ahead.
so in the first method, where it's square root of 16, if we take,
Mhm.
can you take minus 4 instead of 4? If you take the square root.
No. Dekho, clear this. I want all of you to understand this once and for all. If let's say we're figuring out square root of 9, what's the answer going to be? Is it going to be 3, minus 3, or plus minus 3? What do you think? Yeah, I'll
Plus
scroll up. Let
minus-
me explain this. Sorry?
Plus minus 3.
No, it's just 3. Why? Because we don't see any plus minus here. Okay, and if you don't see a sign, that means it's positive. Like, for example, if I just write 2, is this positive 2 or negative 2? Obviously, it's positive 2. When it's positive, we don't categorically write positive. It's understood that it's positive. The only time where you have a plus minus is if you're solving an equation which has square and you get rid of the square by taking the square root on both sides. So if let's say you're doing x squared is equals to 9, now at this point you're asking a question which is what is the number or what are the numbers that can be squared and 9 can be obtained. So that is when you have to take the square root on both sides. And when you do that, you get x equals to plus minus 3. And that makes sense. Why? Because initially the question was what should be squared to give 9? So 3 could also be squared to give 9 and minus 3 could also be squared to give 9. Okay, but here the question is the square root of 9. That's it. So square root of 9 means the square root of 9, which is 3. That's it. Okay. But if you take the square root yourself, that is when you have to take plus minus. That is the only time where you have to take plus minus. Anyway, so here's the, somebody wanted me to scroll up. Yeah, Mubin, there you go. Let me know when you're done taking a look so I can give you guys a question to solve and then we can move on. Okay, so I hope that helps. Now please solve this. Let me know what the answer is and then we'll move on. So for g of f of x, so basically we will find out g of 7 first. So as far as g of 7 is concerned, that's going to be 9. Yeah. And then we're not supposed to find out the value of x. And make sure you're reading the question carefully. And then we're going to find out f of 9, which is going to be 9 minus 1, the whole thing square plus 3. So 9 minus 1 is 8. 8 squared is 64. 64 plus 3 is 7. So that's f of g of 7 is equals to 67. Okay, so I hope it's clear now. Okay, so now we have some slightly different type of questions where we are given the composite function and we have to decide how the composite function was obtained. Okay, so you can see the two functions are given and we have to figure out whether it was h of k or k of k of h. In this question, there's not a lot of we don't have a lot of options, so we can do a bit of trial and error to figure out the exact answer. So I'd like you guys to figure it out. What should I do with the two functions so that I get root x plus 2? Should I plug in k and h? Or should I plug in h and k or k and h? Figure it out. Do a bit of trial and error if you have to. Nothing to worry about. And please don't shy away. At any point, you should never shy away from trial and error.
Sir, is it k of h?
The first part, k of
Yeah.
h, that's correct. So the answer to the first part is k of h. If you don't know how it's k of h, or if you don't know how to do it, like I said, there are only two options. You can either plug in k and h, or you can plug in h and k. So try both. You will see which one works. And that's correct. Part B is h k. Good job. Okay, these were fairly easy, and students usually don't struggle with these two. It's these four that students, not everyone, but generally I've noticed that students struggle with. So I'd like you guys to do these now. This is number 6. Go ahead, take your time. These are 4 parts. Take 2 minutes if you have to. Yes, Varad, I can see you've raised your hand.
Sir, can you please explain the example on top again?
Yeah, sure. So basically, we're given two functions, okay, and we have to decide which composite function will give us. So for example, if we're doing the first part, we have to decide which composite function will give us root x plus 2. Because how many options do we have? Let's try h of k, okay, which means that we take function k and we plug it in h. So how will I do that? I'll basically replace x with root x and then plus 2. So notice, what do we get? We get root x plus 2. So that means the first part is in fact h of k. Get it?
Yes.
In part B, there's only one option that's left. That is, we try k of h. So k of h means that we take function h and we plug it in function k. That means replacing the x with x plus 2. And there you go. We have exactly the function above. That means part B is in fact k of h. Okay, makes sense?
Yes.
All right. Now try question number 6. The first 2 parts are fairly easy. Okay, Sana, you have done part. You might want to recheck part C and part D. I mean, you're on the right track, but you still might want to recheck part C and part D. Yes, C is basically G of G. Yeah, C is basically G of G. And D is F of F. That's correct. So let's have a look. Part A is x minus 1, the whole thing cubed. Now, if you don't want to do trial and error, here's what you can do. You can be a little smart about it. So notice that in order to get x minus 1, the whole thing cubed, we already have a function which has a cube on it. Now what I have to do is I have to somehow figure out how I can replace x with x minus 1. Okay, and that can be achieved by simply plugging in function g in function f. So if I plug in function g and function f, which basically means fg, I can get x minus 1, the whole thing cubed. Okay, so that's the answer to the first part. And feel free to do a bit of trial and error. Okay, कोई इसमें ज़्यादा time नहीं लगेगा. If you do a bit of trial and error, you'll probably be more confident when you give your answer. No, we right after this question, we'll start past paper questions. Okay, these are questions from the book, and we're now starting. After this, we're starting past paper questions, inshallah. Okay, then you have x cubed minus 1. So once again, your thought process should be, how do I replace this x with x cubed? Well, that's easy. That is if you plug in function f and function g. So how do you plug in function f and function g? By doing g of f. Okay. Now part C. So we've exhausted the options of plugging in f and g and plugging in g and f. That means now we have to be a bit creative. So we have x minus 2. So what should I do? Well, with a bit of trial and error, you will realize that this is basically g of g. Why? If you replace x with x minus 1 and then you have minus 1 again, you get x minus 2. Okay, so there's no formula for this. There's no formula that I can give you where you will get the exact answer. You have to use your common sense. You have to do a bit of trial and error. So please don't shy away from trial and error. Now here's part D, which is x power 9. So your thought process should be, well, how do I, if I can replace x with x cubed and then cube it again, you will get x power 9 because the powers are multiplied. So the only way to do that is to plug in function f inside of function f again. Okay, and you will get x power 9. If you can't figure that out, nothing to worry about. No need to feel inferior or something. Just do a bit of trial and error before you have the answer. Okay. Now let's do some past paper questions. So in past paper questions, you will find a mixture. By that, I mean, you'll find exponential functions, maybe even logarithmic functions. No, that's not wrong. If you write it as g square, that's perfectly acceptable. In fact, abhi humne dekha na, why would it be wrong? That f of f can also be written as f square. Okay, so that won't be wrong at all. That'll be 100% acceptable. Okay, so functions f and function g are defined for x belongs to the set of all real values. So f of x equals to e power x, g of x equals to 2x minus 3. And in part 1, the question says f of g of x is equals to 7. So that means we're going to plug in function g in function f. So that means e raised to the power 2x minus 3 is equal to 7. So I hope you guys remember how to solve exponential equations like these. What should I do? How do I solve? That's correct. The only way to solve this is by taking ln on both sides. So let's do that. Let's take ln on both sides. So we have ln e raised to the power 2x minus 3, which is equal to ln 7. 2x minus 3 gets multiplied. Ln e is equals to 1. So that's ln 7. Now keep x as it is till you get to the very end. So 2x is equals to ln 7 plus 3, which means x is equals to ln 7 plus 3 divided by 2. Now work this out and give you the final answer correct to 3 significant figures. So it's going to be ln 7 plus 3 divided by 2. So we get 2.4. No, of course, this will not come in P1. This will not come in P1. So 2.47 is what you get. Okay, that's the answer. Hope it's clear. Now I'd like you guys to solve. So how did you know that this E was that constant, not just... बेटा E कभी वेरिएबल नहीं होता. वेरिएबल जो होता है ना वो हमेशा आपका x, y, z ऐसे होता है. Okay, so you'll never see the question using E as a variable. It's not possible. Okay, so I'd like you guys to now, so these are past paper questions that we're solving. Now, part 1 and part 2 may feel not entirely relevant, but treat them as revision. And I'd like you guys to do this question without my help. I hope. Let me check. Yes, Farad, you've raised your hand. It's 2 into x minus 2 the whole thing square minus 5. Yeah, that's correct. So the answer to part 1 is 2 x minus 2, the whole thing square, minus 5. Good job, fellas. Now do part 2. Part 2 says find the coordinates of the stationary point. So this word stationary point may be slightly new, but stationary point is basically the turning point. Okay, so we're going to do this in detail, inshallah, when we're doing differentiation. Alhamdulillah. Yeah, 2 comma minus 5, that's correct. So 2 comma negative 5. Now it's part 3 that I want you guys to solve, which involves functions. It's fairly easy. See if you can get it right. Minus 3. Let me check if that's the correct answer. So f square of 0 basically means that we will first find out f of 0. So feel free to write it like this. F of 0. So first let's evaluate f of 0. So that I believe is going to be 3, if I'm not wrong. Yeah, f of 0 is going to be 3. Now evaluate f of 3, which is going to be 2 into 3 squared minus 8 into 3 plus 3. So 2 into 3 square means 2 into 9. 9 plus 3 is 12. No, wait, I've done something wrong. F of 0 is 3. So 3 square is 9. 9 times 2 is 18. Oh, sorry, it's 18. Sorry, 18 plus 3 is 21. 21 minus 24 is minus 3. Yes, that's correct. So f of 3 is in fact equal to minus 3. Good job. So, okay, so here is another question which I'd like you guys to solve. Just a minute. It's a 4-mark question. There's a decent amount of algebra that is required to solve this. So go ahead. Okay, so I'll solve. Here's what you have to do. First of all, obviously find f of g of x. So let's concentrate on that. F of g of x means that you plug in function g in function f. So that would be 20 upon x plus 1, the whole thing square, plus 2. So all of this is basically in place of x. Okay, function g in... No, wait. Ulta karte hain. I've plugged in function f in function g. Sorry, my bad. My bad. So we're supposed to plug in function g in function f. Yeah, so we're going to plug in this in place of x. So that means 20 upon x plus 1 plus 1, the whole thing squared, plus 2 equals to 38. Now, don't waste your time trying to expand this because notice what happens. So you have 20 over x plus 1 is equal to 30, the whole thing squared, sorry, equals to 38 minus 2, which is 36. And then what we can do is we can take the square root on both sides so that we can get rid of the square. So we take the square root on the left-hand side, we take the square root on the right-hand side. So remember what happens when you take the square root yourself. So you have either 6 or the same thing, except that it could also be equal to minus 6. Now we may not have both answers as valid. We'll find out, time will tell. So 20 over x plus 1 equals to 6 minus 1, which is equal to 5. 5 ones are 5, 5 fours are 20, cross multiply. So you have x plus 1 equals to 4, which means x equals to 3. Okay, so let's hold on to this answer. Let's see what's up here. So 20 over x plus 1 equals to minus 6 minus 1, which is minus 7. So we have minus 7x minus 7, which is equal to 20, which means minus 7x equals to 27, which means x is equals to minus 27 upon 7. Okay, now don't just blindly reach to the conclusion that both of them are, these are the two values of x. Remember to go back to the domains of both the functions. If as far as 3 is concerned, 3 can be a part of this function's domain and it's also a part of this function's domain. But as far as this is concerned, this is going to be minus 3 point something or almost minus 4, but minus 3 point something to be on the safe side. So minus 3 is not part of this domain, nor is it part of this domain. So that means this is the answer that we will show that we're getting. Okay, so don't think that we're not going to show this answer, but you will clearly also show that you have been able to reach the conclusion that x equals to 3 only is the final answer. Okay, let me tell you something. You might even lose marks if you don't show this. Okay, if you just show x equals to 3 and not this, you might even lose marks. Why? Because it's not just the composite function concept that's being tested over here. The concept that's being tested over here, whether or not once you've solved a question, can you actually make the conclusion as to which answer is acceptable, which answer is unacceptable. Okay, so you have to show both the solutions and then pick one which falls inside the domain.